the distance formula. Okay, you know this already. The distance formula, right? So you are expected to know your distance formula. You see each other in the June examination and so on. You are also supposed to know your midpoint. Okay, how to calculate the midpoint of the line segment. You were taught that in grade 10. So I'm not going to treat you like Mafiki Solos here. Okay, and then the gradient. Sorry, boys, can you pay attention? The gradient of a line segment you were taught from grade 9. Okay, so the gradient of a line segment you were taught from grade 9. You still have to know that, right? Obviously, under gradient, you must know that if lines are parallel, their gradient will be the same. If they are perpendicular, the product of their gradients will be equal to -1. If they are collinear, means the gradient is the same. Okay, if you have got at least 2 points on the same straight line, if those points you calculate their gradient will always be the same. So you're supposed to know these basics. This you can copy later. Right? Then angle of inclination. Now, this is the one which I might talk about in more detail later on, because you can get some level 4 questions on this, including in your June exam, right? You need to make sure you know your angle of inclination. That's very important. Now, angle of inclination is the only concept which is introduced in grade 11, right? So you're supposed to know this as well, the angle of inclination, both for a line segment with a positive gradient and a line segment with a negative gradient, right? Please be aware that for your June exam, we'll test you on all aspects. But you are going to see all aspects of analytical geometry, right? I'll talk about this in the next coming days, right? This is part of angle of inclination. Then the equation of a straight line you were taught from grade 9, okay? The equation of a straight line y equals mx plus c, you were taught that from grade 9. You still have to know that, okay, as you get to metric, right? Then, yeah, that's it. Okay, these are the basics that you're supposed to know, right? So allow me to also just tell you about some of the key terminologies for analytical geometry, like the median, you've got the altitude, you've got a perpendicular bisector. You can read about that. You should have done that in the past. Yes? What? Yes, I'll send one. Right, you can read about it. Yeah, it's grade 10 and 11 way. Listen. All right. Please, don't forget that you are in metric. Don't forget that. So if you are in metric, I don't have the time to go back and start teaching from scratch grade 10 and 11 way. Wait. I'll send you the PDF. Allow me to carry on now. I only have about 5 or 6 lessons to cover grade 12 work. So I cannot spend a full lesson on grade 10 and 11. The purpose, listen, the purpose of this is to allow you to be aware of what you are expected at grade 12 level. So I'm just doing a recap. Okay, a quick recap. Because this is not thorough. So you're supposed to know this. Like when I give you questions later on, okay, you'll be expected to apply some of these. Please don't stress yourself. You won't get questions that require you to know what's the median, what's the perpendicular bisector. They don't test you on that these days. Then you need to know your properties of quadrilaterals. Okay, remember you learned about 6 quads from grade 9. Trapezium, palm, rhombus, rectangle, square, and kite. You have to know this for your analytical geometry. You have to know this, right? The properties of quadrilaterals, right? Then let's start the grade 12 now. All right, I just want to be clear with you. Grade 12, it's only one aspect which is actually taught at grade 12 level. It's called the equation of a circle. Okay, the equation of a circle. That's the only new concept. Okay, So we will talk about the equation of a circle. I think I need a new projector. Yeah, serious, I need a new projector. Okay, can you give me a second? I just need to see if it will work. Okay. The projector is no longer working. Right, I'll get a new projector as quickly as possible. All right, can I have your attention? Right, with regard to the equation of a circle, right, we have got two cases. We've got two cases. So, case one is when the center of the circle is at the origin. So here I write a center at origin. Okay. That's the first case. Now, when you draw a circle with center at the origin, the diagram will look like this. Yeah, it's not good. You just have to accept. All machines, they get to a point where. Yeah, but I need to get a new one. I cannot rely on that. I need to get a new. Yeah, don't worry. Our family has got Mula. All right. Can I have your attention? Yes. We are well. All right. Can I have your attention? Can I have your attention quickly? Right. Before the projector changes the story. All right. So we have got two cases. The first case is when the center is at the origin. So your diagram will look like this. Now, if you want to know the equation of a circle, it's going to be the theorem of Pythagoras. If you have got a center which is at the origin, like in this case, the center will be there. Can you just allow me to recalibrate? So our center is there, right? Now, in most cases, you are going to have a point here at the circumference. Can you pay attention, please? We have a point at the circumference such that the x value is unknown, the y value is unknown. At the origin here, x is 0, y is 0. Right? Please, I want you to be aware that the equation of a circle comes from the theorem of Pythagoras. Okay? And the theorem of Pythagoras is the foundation of the distance formula. I hope you know that from your grade 10. So, if I use the distance formula there, okay? If I use the distance formula, we end up having r squared, which is our line segment, pay attention, is going to be equal to x minus 0 squared plus y minus 0 squared. And this will give you r squared equal to x squared plus y squared, which in analytical geometry, when we are dealing with the equation of a circle, we just write it as x squared plus y squared equal to r squared. So this is the famous equation. Okay, that's the equation there. That's the equation of a circle which has got a center at the origin. Okay, and please be aware that a circle is not a function. Okay, I'm not going to talk about that in much detail, but the reason why it's not a function is because in maths we call it, we say that a graph is a function if for every x value there is one corresponding y value. Okay, you can also have a case where you have two x values giving you the same y value. But if you've got a case where you substitute an x value and you get two y values, that's no longer a function. So you're supposed to get one output. So here, for every x value, like for example, if I choose an x value there, say here, if I go up, I'll get a y value there. If I go down, I'll also get a y value. Because you get two y values for one x value, that causes the circle to be not a function. So as a circle is not a function. Okay, that's the objective of the next topic after analytical geometry. So even though it has got an equation, which is when the center is at the origin, a circle is not a function. Okay, the reason is because for every x value, you always get two y values. Okay, always get two y values. All right. So this is the first case. So you are expected to remember that the equation of a circle with center at the origin is equal to its x squared plus y squared plus r squared. Okay, whereby this r here is the radius. Please be aware that the r is the radius of the circle. Okay, it's a distance. Okay, the r is the radius of that circle. If the radius is not given, then you have to calculate it using the distance formula. Okay, so r is the radius there. Then we have the second case now. This will be case 2. Now, case 2 is when the center of the circle is no longer at the origin. Okay? If the center is no longer at the origin, then we can say the coordinates at the center, we can call the x value A, the y value, we can call it B. Okay? So our A is x and our B is the y value. Obviously, we have an x value at the circumference, so we can call that point xy. And the distance between the center and the point at the circumference, obviously, is the radius. Again, if we use the distance formula here, okay, if I consider the xy point as my x1 or x2, you can end up having x minus a, because a is actually an x value, plus y minus b squared, because b is a y value. This will give you r squared. Okay? And again, this comes from the distance formula, and the distance formula comes from the theorem of Pythagoras. Now, when you write an examination, on the information sheet, this equation will be there. Okay, for a June exam, okay, I'm going to give you the information sheet, like you are writing a final exam. Okay, so this June exam is going to be a true test of your knowledge of maths. Right? So the equation is x minus a squared plus y minus b all squared is equal to r squared. And this is the famous equation of a circle. Right? The first case where the center is at the origin, a will be 0, b will also be 0. Okay? So you need to memorize this, but in examination it's provided. This one here, center at any point. Okay, center at any point, not the what? Not the origin. Okay, center at any point, not the origin. Okay. So if the center is not at the origin, then the equation will be this. And this is the famous equation of a circle. Right? Okay. So make sure you memorize the two equations. The one when the center is at the origin, and the one when the center is not at the origin. Okay? And be aware that this A here, it's an X value. And this B, it's a Y value. Okay? So let's do that now. It's better to strike the iron whilst it's too hot. Yes. Alright, and then there you need to minimize talking as well, right? Yeah, if you minimize talking, I won't talk to you. Yeah, he can take that guess. Yeah, you can take it. You see now, okay. Okay, Ronan, do you see now that we are spending part of our lifetimes because of you?
So he wants to move this up?
Yes.
He wants to move.
Okay. I need to pay. Right, examples. Examples. It's almost broken. But you must bring that one back. Alright. Whilst he's doing whatever he's doing, we need to carry on with the lesson. Alright, examples. Can you please do me a favor? I need to make sure that I have done a few examples before this lesson ends. Okay.